Okay, so in this video, we're going to do converting from mass to moles, because remember, mole's a number, like, so we know, so I just massed out an amount. How many molecules, how many moles do we have? Not how many molecules, just how many moles do we have? So it would be like, I just massed out an amount, how many dozens do we have, right? We're not going to go to actual individual items, right? And then I know how many dozens I have, how much do they weigh? All right, so let's start with something very simple. And some of you are going to say, I can do this simpler, but this is a very easy problem and they're going to get quite difficult. So you want to make sure that you have the setup so that you can do harder problems, okay? So what we're doing today is very, very easy, and it's going to seem very complicated because of the setup, but you must learn the setup, okay? Because they're going to get harder. And then you'll be glad that you have step 1 and step 2, the easy setup, because then when we add step 3, it'll be really easy. Because if you don't do that, then when you start to like, oh, I don't know how to do this because it's getting really hard, well, it wouldn't be really hard if you had step 1 and step 2, because all we're doing is adding just a little bit, right? But you didn't learn step 1 and step 2, so now it's getting really hard, right? Okay, here we go. So, how many moles? Remember, that's like dozen. So how many groups, right? How many groups are of carbon are in 4.3 grams of carbon? Okay, so what we know about carbon is that it has, we know the molar mass. We know the molar mass because it's right on the periodic table, right? So the molar mass is carbon is 12.01 grams of carbon per 1 mole of carbon. Right? We know this. Known. We know that. Okay? So what we're going to do is we're going to start with 4.3 grams of carbon. And then we make this box. Okay? We're going to put this over 1, sort of like if you were doing 5 times 1/2, you would put the 5 over 1, right? Right? You would put the 5 over 1 because it's just a number, and so you put it over 1 so you can multiply those two together. Does that make sense? So we're going to put this over 1. Okay, now, there are 2 rules to this. Only 2 rules. Only 2 rules. Just 2 rules. Just remember these 2 rules. The first rule is whatever unit is here, whatever unit is there, is the unit that goes here. So that's the first rule. Whatever unit is on top, that's the unit that goes on the bottom. And the next rule is, going back to our previous discussion, the unit must stay with the numbers. Unit must stay with numbers. Remember this? The unit has to stay with the numbers. So you cannot say 1 truck 4 tires is the same as 1 tire with 4 trucks, because you have to keep the number with the unit. Those are your 2 rules. That's it. Your 2 rules. The first is whatever's up on top here goes diagonally down to there. And then the second rule is whatever is the unit has to stay with the number. Okay? All right. Let's go. Grams of carbon. Well, I am trying to find out how many moles of carbon are in 4.3 grams. I have grams of oh wait, look here. I know that 12.01 grams of carbon is equal to 1 mole. So this is like a conversion factor here, right? Because if I use this, I can go from grams of carbon to moles of carbon. So since grams of carbon is right here, I'm going to put grams of carbon, 12.01. Why do I put 12.01 at the bottom? Because the unit must stay with the number. So since grams of carbon is down here, 12.01 has to go here. Then what goes on top? 1 mole of carbon. Now, in fractions, top and bottom cancel. Top and bottom. So my grams of carbon cancel because they're on the top and the bottom. And that leaves me with moles. Wait, what was I looking for? Moles. How many moles? So all I'm going to do is divide 4.3 divided by 12.01 equals 4.3 divided by 12.01 equals 0.36. 0.36 moles of carbon. That's my answer. Because I canceled my grams of carbon, so all that's left is moles of carbon. Why did I cancel my grams of carbon? Because they were on the top and the bottom. Why were they on the top and the bottom? Because I started with grams of carbon, and the rule is whatever I start with on top goes to the bottom. Why did I divide by 12.01? Because grams of carbon was here, and I know that grams of carbon, 12.01, so the 12.01 has to stay with the grams. All right, let's do another one. I know, you're going like, what? Don't worry, we're about to move to the back. Ready? Here we go. I would like to know how many moles of ammonia, NH3, are in 6.7 grams of NH3. So the first thing we need to do is calculate the molar mass of NH3. So 1 nitrogen and 3 hydrogen. So now I look on my periodic table. 1 nitrogen is 1 times 14.01. And then 3 times 1.008. So I get 14.01 and 3.024. I'm going to add 17.024. Can somebody give me the units for that molar mass, please? George, can you give me the units for the molar mass? Take your time. No rush.
Grams of
Ammonia.
ammonia to moles of ammonia.
Excellent. Excellent. Grams of NH3 over, good job, George, over 1 mole NH3. Okay. Now, I need to calculate how many moles are in 6.7 grams. Yes, Jackson?
Would it be 17.034? 7.024?
No, because 0.08 times 3 is 24. Oh, plus the 0.01. 3.4. Thank you. You're right. 3.4. Good job. Thank you. Sorry. 3.4. Okay. All right. So now I'm going to take, thank you for paying attention, 6.7 grams of NH3. And do I need to put the one underneath? No. But if you're curious as to why this is sort of hanging out here, same reason. Like, do I need to put the 1 under the 5? No. But if you want to, you can. Okay. What unit goes down? Sean. I know, this is a hard one because we've only done one problem. What goes down here? Being wrong is acceptable. What unit? That's not a unit, that's a compound, but you're on the right track. Grams, it is. Grams it is. Do you know why, Sean? Nah. All right, close enough for government work. All right, the reason it goes down is because whatever is up here goes down here. That is rule number 1. There are only 2 rules. Rule number 1, whatever is up top goes diagonally down. Rule number 1. So I'm going to put my grams of NH3 here. And I'm trying to find out how many moles there are. So I have a conversion here that works very nicely because I have moles and grams here. See that? I have moles and grams, right? Bella, how many grams go on the bottom of that box? Being wrong is perfectly acceptable. So I'm looking for this number. Is it like how many, what's that number going to be? So, okay, we're going to look here. You're looking here. And remember, the rule number 2 is the unit and the number must stay together. Yes, it's going to be 17.034 because we do not want 1 tire and 4 trucks. We want the unit and the number to stay together. Those are the 2 rules. The first rule is the number at the top is going to come down, and the second rule is the number and the unit must stay together. That's it. Because what's left? What's going to go on top? There's only one thing left. Right? What's going to go on top? Julia, what do you think? How many? Yes. 1 mole, that's all that's left. So we're going to put the 1 mole on top. And now I'm going to cancel my grams because top and bottom will cancel. And all I'm left with is 1 mole. That's all that's left. 1 mole. I got nothing else, ladies and gentlemen. That's all I got, right? And so therefore, now to solve this, I'm going to take 6.7 and I'm going to divide by 17.034. And what I get is 0.39. 0.39, and my unit is going to be moles of NH3. How are we doing? We do not understand this. We get the basics of it, but we are really clueless, right? Great. Then it's time to go to the back and go to the boards. You ready to go to the boards? You will need your periodic tables, and we're going to the boards. And for you at home, there's practice problems. I'm going to post them on a worksheet. Okay.